Hello friends, welcome to our J Multiverse channel. Today we will be going to cover a very important rule of differentiation. So please share this lecture as much as possible and please subscribe our J Multiverse channel so that we put more and more content on our channel, okay? So this is again a very important rule of differentiation. In last lecture I have taught product rule of differentiation. Today we will be going to cover another rule of differentiation, which is quotient or division rule of differentiation. Okay, so we can find easily the derivative of, let's say, y equal to sin x. Then we can easily find derivative of this function, okay, that is y dash equal to cos x, that we know, okay. And also if we are given with y equal to x square, okay, then we can easily find derivative of that is 2x. But now let's say we are given with a function which is sin x by x square. Now how will we going to find the derivative of this function? So okay, we have two ways. First, we can apply product rule. How? That is, write x to power 2 1 upon x to power 2 as x to power minus 2. So x to power minus 2 sin x, like this. And now we can easily apply product rule, which is y dash equal to derivative of first function into second function as it is. So minus 2 x to power minus 3 sin x plus derivative of second function, which is cos x, into first function as it is. Or we have another rule of this type of equations, which is quotient rule of differentiation. Okay, so y equal to sin x by x square. Okay, so now let's say this is method 2, this is method 2. Okay, so now let's say that sin x is our first function and x square is our second function. Now we have to find y dash. Okay, so y dash is what? Derivative of first function, means derivative of sin x, which is cos x, into second function as it is, minus okay, this is minus sign, minus, okay, let me write so that we can get more space. See, y dash equal to derivative of first function, which is cos x, into second function as it is, which is x square. Okay, minus derivative of second function, which is 2x. Okay, derivative of second function means derivative of x square, that is 2x, into first function as it is. Okay, now this whole expression divided by square of second function, means square of x square, that is. Okay, so this is our quotient rule of differentiation. This will give us the same result, means let's say we are given with y equal to fx by gx. Okay, these are two functions, fx and gx, and they are dividing each other. Okay, so this is our first function. Now in this case we have to assume numerator function, which is in numerator, is first function and function in denominator is our second function, because here this will matter. If we assume denominator is first function and numerator is second function, then the result will be different. Okay, so we have to assume numerator as first function and denominator as second function. Okay, so from this we can write y dash equal to derivative of first function, which is f dash x. Let's say derivative of fx be f dash x. Okay, that is a way of representation. So derivative of first function, which is f dash x, or we can also write it as d of fx by dx, or we can also write it as f dash x into second function as it is, minus derivative of second function, which is g dash x. Okay, derivative of gx, let's say that is g dash x, into first function as it is, fx, and this whole divided by square of second function. Okay, and now let's assume that if we take numerator as our second function and denominator is our first function, then what will happen? Then y dash would be derivative of first function, which is g dash x. Okay, g dash x means derivative of gx into second function as it is, minus minus derivative of second function, which is f dash x, into first function as it is, upon second function whole square. Now clear we can see that both are giving different result, and this is our correct result. Okay, and this is wrong result. So we can see that if we assume the numerator second function, then it will create a chaos in our answer. So it will be better that we will take numerator is our first function and denominator is our second function. Okay, so this is our quotient rule. So let's do some questions on this. Okay, let's say we are given with a function y equal to x square plus 3 upon 3x plus 5. So again, let's find dy by dx. So just pause your video and try this yourself and then see our solution. Okay, so let's solve this. Okay, so y equal to x square plus 3 upon 3x plus 5. So means this x square plus 3 is our first function and 3x plus 5 is our second function. Okay, so y dash means dy by dx, this is equal to derivative of first function, which is 2x plus 0, because derivative of x square plus derivative of 3 and derivative of x square is 2x, so derivative of 3 is 0. So 2x into second function as it is, that is 3x plus 5, plus now derivative of second function. Okay, derivative of second, no sorry, not plus, it's minus. Okay, so derivative of second function, that is 3. Okay, so derivative of 3x plus 5 is obviously 3 into first function as it is x square plus 3 divided by second square of second function, means square of 3x plus 5. So this is our answer. Okay, now you can simplify as per your need, but this is the main expression that we can derive with a quotient rule of differentiation. Again, let's try another one. Let's say y equal to sine square x by cos square x. Now we can easily find this with the help of chain rule, but we does not know chain rule now, so we have to find this in another way. Okay, now we can use identities of trigonometry here. So I have taught that cos 2x, okay, cos, in this chapter only I have taught in the portion of trigonometry that cos 2x can be written as 2 cos square x minus 1. So from this we can write cos square x equal to cos 2x plus 1 by 2. Can't we write this as this? Yes, we can write it. Okay, no issue on this. And also I have taught that we can write cos 2x as 1 minus 2 sine square x. Remember, I have taught this also. From this, sine square x would be written as 1 minus cos 2x by 2. Okay, so now replace value of cos square x and sine square x in y. So y equal to, what is our function? That is sine square x by cos square x. So sine square x by cos square x, and we can write it as 1 minus cos 2x by 2 upon 1 plus cos 2x by 2. Now 2 and 2 will get cancelled and we will get y equal to 1 minus cos 2x upon 1 plus cos 2x. And now we can easily, no, now we can't find the derivative of this function because again chain rule will be used. So just let it go. Okay, let this question go and we will find this by chain rule. Okay, so because here cos 2x is there, not cos x, so we need chain rule to find its derivative. So let's skip this question here. Okay, let's try another simple one. This is not that much simple. Now let's say y equal to x cube plus 3x square plus 4 upon sin x. Now this is easier one. Okay, so we can find its derivative easily. Now okay, let's try a different function. Let's take it to be e to power x. Or I have also taught derivative of e to power x. Remember, I have taught this in the lecture that's name is derivative of important functions. If you forgot that, then please go and revise that all. Okay, and that is important, that all functions need to be learned. Derivative of all function need to be learned. Okay, that is basic requirement. So y equal to x cube plus 3x square plus 4 by e to power x. Right, now we have to find dy by dx. Okay, so dy by dx would be derivative of first function, means derivative of numerator function, which is derivative of x cube plus 3x square plus 4. That will give us 3x square plus 3 into 2x, okay, plus 0 this, okay. And if we write directly in simplified form, then it will give us 3x square plus 6x into second function as it is minus derivative of second function. Now in case of this type of exponential function, which is e to the power x is a constant, okay, is a type of constant, okay, then this will be valid only for you, okay. Then derivative of e to the power x will be same e to the power x, okay, and this is valid only for e, not for other values such as 2 or 3. So derivative of 2 to the power x and 3 to the power x would be different, but derivative of e to the power x would remain same as e to the power x, okay. And so 3x square plus 6x into e to the power x minus derivative of second function, which is e to the power x, and its derivative will be remain same, that is e to the power x only, into first function as it is upon second function, which is e to the power x square of second function means. So we can, so from now we can easily find derivative of such functions, okay. But if we want to find derivative of this type of function, then we need a chain rule, okay. We need chain rule, and we will study that in next lecture, okay. And that is much complex to be understand, so I will taught in as easier way, okay, in that way that it will be easier to understand for you. So let's try one more question, and this is the last question for this lecture, okay. Let's say we are given with our function which is y equal to sin x by x plus cos x. Let me check it would be derivable with quotient rule or not, okay. So wait for a while. So okay, we can derive this easily, okay. So by product rule, division rule of differentiation. So dy by dx equal to dy by dx would be derivative of first function, which is sin x, means derivative of sin x, which would be cos x, into second function as it is minus, okay, it will be minus not plus, so take care of sign, okay, minus derivative of second function. Now derivative of x plus cos x means d of x plus cos x by dx, we can write it as dx, d of x by dx plus d of cos x by dx. I have taught this. We can find derivative of other this type of function in by splitting it, okay. So we can find derivative of x and cos x differently, separately, and then add it directly, okay. So this would be derivative of x, that is 1, plus derivative of cos x, which is minus sin x. So this would give us 1 minus sin x. So derivative of x plus cos x would be 1 minus sin x. So minus derivative of second function, which is x, derivative of x plus cos x, which is sin x, into first function as it is, and this whole divided by square of second function, which is square of x plus cos x. Okay, let's try one more and then we will finish our lecture. So y equal to cosec x by x square plus 3. This all type are similar, but just for practice it will be much better if we try more and more questions. And okay, so let's solve this one. Y equal to cosec x by x square plus 3. So our first function is cosec x and second function is x square plus 3. Now dy by dx would be derivative of first function, which is derivative of cosec x, okay, and derivative of cosec x is minus cot x into cosec x. Yeah, I have taught this, okay, okay. So that is derivative means derivative of important function. In that lecture I have taught derivative of cosec x, which is minus cot x into cosec x. So minus cot x into cosec x. Okay, wait, let me write it in better way. I am directly writing y dash, okay, not dy by dx due to lack of space. So minus cot x into cosec x, they are in multiply, okay. This means derivative of first function into second function as it is, minus derivative of second function which is 2x into first function as it is, this whole divided by square of second function which is square of x square plus 3. Okay, so y dash equal to, okay, we can simplify it better as per your need. So I am leaving this homework for you to simplify this function if you can, and there is no issue. Okay, so that's it for our lecture. If you like our lectures, then please give like to our videos and subscribe our J Multiverse channel and share our videos as much as possible. And thanks for watching.